All right, thank you, everyone. Sorry for the slight delay. We had technical difficulties, but we can begin and officially welcome you to the Coding Summer School 2024. So let's get into it. So the agenda for today, we're going to just look at a brief welcoming, introductions, who was involved with this Coding Summer School, setting it up. We're going to hear from the CHBC Research Manager and the NITHEX Director. We're going to have a brief introduction to a few of the champions that have been involved with it. We'll give each of the champions each day just to give a bit of an overview of what they've done and who they are. And then the overview of the course as well, translation of content, schedule, and logistics. So yeah, that's the agenda for today, and hopefully we won't take too long for that. All right, so myself, Benjamin Bosch, I'm the lead coordinator for the Coding Summer School. Then the rest of the team from HBC, Dr. Vanessa van Rensburg, Mr. Mateto Savaro, Dr. Kevin Koval, Dr. Fupi, Mr. Sam Mateja, and Mr. Brian Johnston. So that's from the CHBC side. From the NITHEX side, Mr. Rene Kotze, Mr. Alimane Kuka, and Mr. Malu. All right, so for one, myself and normally we'll be doing the training for week one. And then we have quite a diverse group of lecturers and trainers week two, but I'll rather let Prof. Francisco discuss that. Ask everyone to mute their mic, please. I hear a bit of feedback. Just do it for you. All right. And just to kind of get a bit of feedback from the champions, again, this was quite a venture to kind of allow everyone to be part of this. So actually, yeah, maybe we can before we get Francisco and Werner to give the introduction, I wanted to first get maybe Mattia just to give a brief intro as well, if you want. Yeah.
Thanks. Oh, hello, everybody. I am Mattia Vaccari, and I'm a professor of astrophysics at the University of Cape Town, but here I'm mostly helping out as the UCT e-Research Director, which is an initiative to bring together IT services, library services, and research office support services to help researchers and postgraduate students getting the most of the new digital tools, including code, new programming languages, and artificial intelligence and machine learning. And we're very happy to have Benjamin and his team here at UCT for week one. But yes, I guess that we have a long range of people to do the introductions for. So I think that'll be me.
Thank you. Thanks for that. And then maybe we can get Nancy from Timber Labs. Are you there? Nancy?
Yeah, good morning. Can you hear me?
Yes.
Yes, so this is a group from Timber Labs. It's a great pleasure for us to be part of this 2024 Coding Summer School. And Timber Labs deals with nuclear-based research, but it's a group that is working on nanomaterial-based research under Prof. Malik Mother and other doctors and senior scientists. So some of the applications of our research in this group include drug delivery, water splitting, electronics, coatings, and biosensors, to mention a few. And the group is excited to be part of these workshops as it will equip them with the necessary knowledge to apply in their research work. Thank you so much.
Yeah, no, I noticed that as well. Thanks for that, Nancy. I will have to see to that afterwards. Next one up, Albert van Eck, can you give a brief intro?
Sure, thanks, Benjamin. Albert van Eck, I'm from the University of Free State. I'm the director of the High Performance Computing Unit and e-research unit on campus. So anything computational intensive comes through our offices at some stage, hopefully. Yeah, we just assist students and researchers on campus with their computations. Thanks.
Thanks for that. And Krishna? Sure, so coming through.
I guess you can see me now. Okay, so I'm Krishna Govender. I'm from the University of Johannesburg, the Department of Chemical Sciences, and I am a computational chemist and material scientist. So basically, we do everything chemistry related on the machines and make use of high performance computing in order to do all of the research we do in the group.
Well, thanks, Krishna. Andrew from Stellenbosch University.
Hi, my name's Andrew Gill. I'm from Stellenbosch University, Department of Mechanical Engineering, Mechanical Mechatronic Engineering. So I've been trying to organize things from the Stellenbosch side. Is there anything else I should?
Thanks, Andrew. Daniel from Northwest University, Potchefstroom.
Thanks, Benjamin.
And actually,
Sorry? No, I didn't put my picture. Okay, sorry. I'm Daniel Moketi from Northwest University School of Physics and Center for Space Research. I actually started this project many years ago. I'm in summer school when we call it Introductory Programming School in 2011. So I'm glad that it has grown so far now. So yeah, we have all the students, I think more than 40 in this lecture hall. Thank you.
Thanks, Daniel. Dr. Fielder from WITS.
Hi, everyone. Benjamin, can you hear me on your side?
Yeah, go ahead.
Yeah. Hi, everyone. My name is Atiba Guys Bakanye. I'm a PhD student in atmospheric science at Wits University. And I'm a champion for the Coding Summer School. I am with John, who is a computational material scientist, also at Wits. And I am with Tamron.
Cool, thank you.
With Tamron, who will be our tutor.
You can see all the students there.
Student and PhD students. Thank you.
Thank you. Next up, I would like to get the our research director or research manager at the CHPC just to give an introduction as well. I'm going to stop sharing, Werner, so you can share on your side.
Thank you, Benjamin, and thank you to everybody on the line and for this opportunity. This is indeed a huge undertaking, and I want to start off first off saying thank you to Benjamin for coordinating this. From the CHPC side, we are extremely proud to be involved in this project. We've been doing this kind of training for many years, but this has now grown to I think a level of sophistication and involvement that all of us are very proud of. So I thought just to take about 10-15 minutes, just talking a bit about the CHPC. I realize that some people on the line are users of the CHPC, but there are many that are not users. And you may be wondering why is CHPC and NITHIX collaborating to host this? I see Francesco, you are on the line as well. Good to see you. When we think about CHPC and NITHIX, our goals are very much aligned to support this community and very much on the computational sciences part of this. So I'm just going to give a before Francesco comes on, I'm going to give a very brief presentation just on introducing the CHPC. So I will maybe skip through a few slides quickly, but you will get the slides. This is in any case recording. So let me just put this on quickly. And Benjamin, then you can maybe just indicate if you can see the full screen on your side, or is it the wrong way around? Can somebody maybe confirm? Is it looking good? Okay. So just very, very quickly, this is the 2024 Coding Summer School. I've lost count now. I think it's from a CHPC side, it's about the 15th time we're doing this event. We've been collaborating with NITEX on this for the past 6 years already. Having all kinds of combinations of the event, whether initially just physically hosted events where only a selected number of people could attend. Then in COVID, we went into virtual training completely. And now we've evolved this to the hybrid model where people are physically in rooms mostly, and then we also present it virtually. So this is why I'm certainly very excited about this and the reach that this is getting. But just on the Center for High Performance Computing, maybe just briefly to say, well, just a word or two on what about HPC and the CHPC itself, our users, our usage, what we do for training and development, and then the practical side of access to the CHPC, because this is very much about giving people the message about what access you have to state-of-the-art computational resources in the country. So I always like to start and say, well, what is high-performance computing? Is it really that special? And my message to people is, in principle, no. When we think about high-performance computing, we simply are thinking of basic computers. Everybody knows a desktop computer with basic components, processors, memory, storage network, that kind of thing. So if you want to think about high-performance computing, think about combining this together, as many as you want, to use the combined power of this. So it's about components that you add together to really do, say, a single calculation by utilizing all. And of course, you put it together in a special way. We put it in these compute racks, but it's all about the interconnects between these let's say, different computers or nodes of computers, and we put it into a cluster. And this is the compute cluster. And the message is essentially that, yes, the processors, the memory, the storage network, all those components are still there. It is just put together in a way to efficiently make use of all of the compute equipment. So if you can do your simulations on a desktop computer, or maybe one or two of them, there's a chance that good you can do it on a dedicated compute cluster or a high-performance compute system. And when we talk about supercomputers or high-performance computing, this is the same concept. And where does the CHPC fit into this? Well, maybe first more about HPC. I mean, what do? We take computing and we distribute or make it parallel over all these compute nodes, typically over many cores. Typically, a computer might have 8 cores per node or so on, but you put these nodes together, you put it into a cluster. And typically, when you only execute on one computer, say 1 core at a time, you do serial programs, you execute sequentially. Whereas parallel computing is, of course, breaking up of these serial algorithms in separate parts or threads to be executed on many cores simultaneously. And you might ask, well, what is the... You say, well, yeah, it's quicker. You can maybe do the calculation that you did on your computer that took half an hour. You may be able to do this now in 2 minutes. So why is that so important? I think the main message here is that access to high-performance computing makes simulations possible that could otherwise be impossible or unrealistic to do. And I think this is where the importance of researchers having access to high-performance computing comes to the fore. It is that you can do things that you otherwise would not be able to do. And the need for this in the format of a national facility for South Africa was recognized many years ago already, more than a decade. I mean, now it's about 16, 17 years ago, in 2007, for this national high-performance computing facility. And this is what the CHPC is. And if you think about high-performance computing, almost any domain you can think of in science and engineering can benefit and should benefit from access to high-performance computing. I'm just putting a few pictures on the screen there. But the possibilities are limitless, and these days it goes well beyond scientific and engineering applications into the humanities as well. So even the design of Pringle chips, you can go and look at that link. High performance computing, the shape of that chip, high performance computing was involved in that. So the CHPC is the National High Performance Computing Facility for South Africa, and it is funded directly by the South African government through the Department of Science and Innovation. And this is hosted in an entity that we call the National Integrated Cyber Infrastructure System. You will see this logo quite a bit. Let me just put my laser. You will see at the top here, there's a NICIS, and you will see this NICIS everywhere. And this is the entity that the DSI is funding, the National Integrated Cyber Infrastructure System. I'm going to say a little bit more about this just in the next slide. But we are administered by the CSIR, so that's why the CSIR logo is here. And we started operations already in June 2007, based in Cape Town. And until recently, we hosted the largest HPC system in Africa. We say until recently because there is now a bigger system in Morocco, but for many years, the system at the CHPC has been the largest. And the CHPC has a total of about 35 employees, and it's divided into research technical operations. And my focus is on the research support side, so everything user related. So just to emphasize, we're based in Cape Town, the front of our building. Everybody that's interested, if you get to Cape Town, you want to make a visit to the CHPC, we're always very welcome to visitors. We would like you to come, so please come. The National Integrated Cyber Infrastructure System, NICIS, this is what the DSI is funding, and it consists of 3 important legs: computing services, which is the CHPC, but also networking services, SUNRING, South African National Research Network. All academic institutions, public institutions are connected through this high-speed bandwidth connectivity already. And the other one is the DRISA, the data services, Data Intensive Research Initiative of South Africa. And the main message here is that all 3 of these components are needed for researchers these days. It doesn't help to only have a big computer situated in a data center if users cannot access it quickly from a remote place, or if your data services or your storage needs are not addressed. And all of this are in place at the moment, so users can benefit from it. And certainly we can discuss this further. But the CHPC is all about the computing services that we render. So at the CHPC, we have the state-of-the-art cluster. It's a 1 petaflop cluster. So in terms of performance of clusters, this is a standard way of determining the performance of any computing device. You can classify how fast it is compared to any other computing device. In South Africa, we've got a petaflop cluster, just over 1,000 teraflops. And this was Africa's first petascale system. And when it was launched a few years ago now, 2016, the second phase, 2017, it placed around 120, 127 on the top 500 list of supercomputers. And I always say this is significant because at that stage, it was the only computer or supercomputer from Africa on the list. And I think this is why we are proud to host this offering at the southern point of Africa, but also for not only South Africa, but the whole region to benefit from this. It has since dropped off the list. These days, if you want to have a system on the top 500, it needs to be around 2 petaflops. Then you will get into about position 500. So this is just an indication of how the computer technology is evolving. But although this system is old, it is still fully utilized by researchers. And it is now getting to the end of life stage where we are upgrading. So this year, 2024, we will see a significant upgrade to this cluster, which we will announce when more details are unknown. So just to emphasize, any respectable computer or supercomputer needs to have a name. And this one is called the Lengao Compute Cluster. And Lengao is the Setswana word for cheetah. And I think it is quite obvious that the emphasis here is on speed, not only speed, but on being the fastest. And this is what we strive to be, not only for South Africa, but for the African continent. There's some details on this cluster, almost 33,000 cores connected together in nodes, 56 gigabits per second connectivity between the nodes, and a 4 petabyte parallel storage. This is the kind of support infrastructure you need to run a cluster like this. We also have a GPU cluster, 30 NVIDIA V100 nodes. This is also going to be upgraded this year, but it is very much in demand by chemistry users, molecular dynamics, and of course, machine learning training models and so on. We also have a production cloud called Sabawa. It was launched in 2020, and this is used by many researchers to host their own services. So if you are interested in cloud services from the CHPC or NICIS, you can talk to us. It's still modestly in size, a modest size, but we are planning to increase this as well. So what is the mandate of the CHPC? And I think it comes back to all of you on the line, is that we are very much a research enabler. And like our director wants to say, not only an enabler, but an accelerator of research in the country. And the point is that if you want to be competitive in research these days, you need to have a strong modeling and simulation component to your work. This is just how nations these days compete. And HPC capacity is actually a measure of this. So we do this by providing computational resources. If you look at those 3 bullets, basically to everybody, even the private sector, but mostly to the South African academic research communities. If you're an academic institution, you can use this facility essentially for free. And we do this research enabling role, well, firstly, access to the compute hardware, but also to a next level where we do code and software support. And then even further, we do have appointed or in-house research domain areas or experts where people give direct support to research domain areas. And then also training and education like this summer school is very much part of our focus. And where our training is typically done not by dedicated trainers, but people that's actively working at the CHPC in other roles. So yeah, dedicated domain specialists. You can see the kind of domains there that we are supporting. We have a dedicated technical support team that looks after the management and support of our cluster. We have a dedicated advanced computer engineering laboratory. It looks at advances of the HPC, testing the next generation systems and advising. And then, as I mentioned, all of the above are the trainers of different events. So if we look at this Lingao compute cluster over the years, this is just all-time usage since April 2016. You get an indication of the number of research programs, total active number of users that's been involved. So you can see it is quite a large number. And if you look at how the distribution of research programs, the South African academic community is about 80% of research programs, as it should be. This is where research is being done and why the resource is there, but also other important entities like public institutions, South Africa, our African partner countries, and a small segment of private sector use. If you look at the universities only in South Africa, while diverse utilization is there's not one university that uses, say, the bulk of the cluster. Not all 26 entities are represented yet, but we are getting there. So this is a good reflection on the purpose of a national facility. And also, if you look at the different domain areas, yes, material science, chemistry is quite a big one. It constitutes about half of the hours being used or the programs on the cluster, but we do have a very large community, but other research domain areas is also very well represented. So training and development, this is an important focus for the CHPC. There's many different training programs or events that involves training, but the introductory programming, as it was previously called and now called the Coding Summer School, is a key one. This is where we would like to provide, say, especially new and inexperienced users the opportunity to learn skills to effectively make use of this computational resource that we have at the CHPC. And of course, linking this strongly with the mandate and focus of NITHEX to advance the computational sciences as a way to do research in the country. So with that, I'm going to not talk about this slide. This is going to be in the recording. In the slides, you will get all the links you may need for practical access to the CHPC, my email address. If you want to start using the CHPC, you go up and go into those links, read about it. We will be very pleased to accommodate you. And then just thank you. I think Benjamin, you already indicated the large number of people involved. But yes, the DSI, our funder, of course, Professor Francesco Piccioni, our collaborator at NITHEX. NITHEX team, you took the name on the screens already, Benjamin, the CHPC trainers and colleagues. This is a huge team effort. But I emphasize again from the CHPC side, Benjamin is taking the coordinating role has the coordinating role, and he's been working on this together with the team for months. So this is the culmination of preparation over a long time. Many external lecturers and contributors, also the champions. Without you, we cannot do this. And of course, lastly, the Coding Summer delegates, Coding Summer School delegates, all of you on the line in the rooms, please make the most of this. The success of this is only going to be determined by how well this is received and how much you make of it. So we will be keen to hear also from you afterwards. So Benjamin, with that, I'm going to stop sharing. I just need to find a place where to do it. Yes, and thank you then for the opportunity to give this brief introduction. Over to you, Benjamin. Thanks.
Well, thank you, Werner. Prof. Francesco, you can go ahead. You're muted, Prof.
Can you hear me now?
Yes, a bit soft, but go
Okay.
ahead.
Sorry. We have two unmutes, one on the system and one of the on the laptop of Andrew. Sorry. So good morning, everyone. My name is Francesco Petruccione. I'm the interim director of NITEX, and I'm also very pleased for NITEX to be part again of this initiative this year. Werner just gave you a little introduction on the CHPC. I will give you a short introduction on NITEX because we are running a bit late and you want to learn some lineups. Huh? So NITEX is the National Institute for Theoretical and Computational Sciences. Yeah, it's a new national research facility, also sponsored by DSI / NRF, the National Research Foundation. It is a consortium of essentially all universities in South Africa, including AIMS, the African Institute for Mathematical Sciences, and its hub is in Stellenbosch, just across the bridge from the building in which we are standing and sitting here at the moment. Yeah, NITEX is an institute that caters essentially for all the basic sciences. Yeah. It has a total of 8 disciplines that we support. Yeah, there is theoretical physics, mathematics, astrophysics, statistics, data science, bioinformatics and quantitative biology, quantitative finance, and space physics and climate change modeling. Yeah. So it's you see it's a multidisciplinary institute that has about 250 research associates scattered in the country. Yeah, I like to sell NITEX as an undisciplinary institute. Yeah, because we want to solve big problems, and the discipline in which people are working or training is sort of, I don't want to say irrelevant, but not so relevant as the solution of some big problems. Yeah? In the mandate of NITEX, there are essentially four pillars. Yeah. There is research, of course, because it's a national research facility, but there's also training and engagement and opening up to the African continent. That's why in this edition of the summer school, we have also some African universities involved officially for the first time, and we are very happy about that. Yeah. The summer school with the CHPC is part of our training endeavor. Yeah. And we have lots of other activities during the year that might be of interest for you. Yeah, for instance, every Monday, starting I think next week or in February, yeah, we have a colloquium covering some topic about the 8 disciplines. Every month we have what we call a mini school, yeah, which is devoted to a more specific topic. Yeah, a little bit of a summer school in short for lectures once a week. We have introduced last year also master classes, and in fact we have a series of master classes once a month. This is typically a 2 hours event on some topic around artificial intelligence. Yeah, the next one is I think sometime mid-February. Yeah, we also partnered with the Carpentries, yeah, which is a non-profit organization whose aim is also to train into scientific computing. So it's after this summer school as an appetizer, you want to learn more, please join our mailing list, follow the NITEX website, and you will see that almost every month we organize another training event around scientific computing, from bioinformatics to data science. Yeah. Yeah, so those are some of the things that we do. And I really encourage you to join our mailing list so that we can send you the information and you don't miss out. Yeah? All our events are also recorded so that we have a YouTube channel with hundreds of videos, if not maybe thousands by now. Yeah, so you're welcome to browse there and find things there that might be of interest for you as well. Yeah. So I would like also to finish here now again by thanking our co-organizers from the CHPC and also all the champions at all the universities, because without them all this would not be possible. And here in Stellenbosch, where I'm standing, a big thank you to Andrew, who's organizing this beautifully. Thank you very much.
Thank you. Okay, so thank you for all those introductions from CHPC and ethics. So let's go into a bit more detail about the Coding Summer School and why we're all here. Yeah, so I'll just first look at some numbers that we have. So we have about 802 participants from around the country. You can see the figure presented here. We have pretty much every university represented, as well as 2 research institutes in South Africa. So we did start this last year to have a hybrid event where we try to include all the universities and institutes, and we have increased about 10% by the amount of students that participated this year. So very excited for that. So in total, we have about 30 venues around the country, as well as our partner universities in Kenya, as well as Ghana as well. And just note, because we had such a huge collaboration, it took about 6 months planning to get all the universities to work together and to arrange this. So it's quite a feat to be able to do this. In terms of amount of champions we have, and champions, they're just lecturers at the universities that arrange the venues and coordinate with students. So a lot of effort went into preparing for the Coding Summer School. In total, again, we have about 10 staff shared between NITHIX and the CHPC, as well as we have about 30 tutors that will help students as well during this time. So this is an important statistic that was gathered from all the students that did register. So you can see the top 4 domains, also the top 5 domains. Primarily, we have the physics domains, then chemistry, biology, engineering, environment, and geography. Those are top 5 domains, and then we have the other domains split as well. So it's useful to see the broad spectrum of students that are coming from the different universities and the different research domains. So again, we try to cater for everyone to some degree. That's why we've catered, the week 1 for introduction to Python and data science skills and a bit of Linux and Bash. And then week 2 is more application Python topics. So hopefully it'll actually benefit everyone. And that is the idea behind it. And just to look at some of the top, fields of study as well. So you can have a look at the list. I mean, it's quite a long list. It's longer than this one. So if you can see one of your research areas specifically here, this is just to kind of show you the vast spectrum of students and teams that they're in. So know that you're not alone, and there are people in your own research area that's part of the summer school. Okay, so again, week 1, this is a course for beginners, specifically for students that have very little introduction to programming and Python. However, we have catered it to kind of make sure you benefit in some way or form. So we're looking at, it's a different type of approach to training Python. So we're looking at using a theme of data science and data engineering skills, and starting from the ground of Excel. Everybody knows, well, you should know about Excel and using spreadsheets. And I think about 25% of all the participants of the Coding Summer School use Excel only for their research. So everyone else obviously does. So this is our ground truth. This is what we're going to work based on. And in day 1, we're going to get you to, working with your spreadsheets in Python itself as well. So a bit of a different approach to learning Python for beginners. We are very application oriented, very little theory, and just, making sure you're getting things working as soon as possible. Again, we're trying to teach practical skills. So we're gonna, allow you to get to use GitHub as well. If you don't know what Git or Git repository is, we'll look at that too. And an important skill as well is learning file management, specifically in a Linux environment using a Bash terminal, but we'll cover that a bit later. Week 2 is a bit more application oriented in terms of what you'll be learning. So Monday and Tuesday, that's machine learning. Wednesday, probability and statistics. And all these days, from today until next week, Wednesday, these lessons that you'll be taught, everyone should benefit from it. It's very general, and you should be able to benefit to some degree. Thursday and Friday is kind of split into 2 different domains. Thursday, more physics and math domain areas. Friday, chemistry and bioinformatics. We will have pre-recordings of astronomy and environmental sciences as well, that you can kind of view beforehand. So again, we try to cover all the domains, but again, it's just a basic introduction in these domains, how to use Python in these fields. Yeah, so hopefully you will benefit from it. Okay. All right, so this is a quite important mandate, part of the CHPC and NITHIX, moving while trying to transition to not only use English as a primary teaching medium, but using all the African languages, specifically South African languages as well. But I'll prefer to ask my colleague and pioneer of this mandate, Mr. Mteto Savara. So, Mteto, are you there? Mteto? Don't see him there. Okay, we'll maybe ask him to do his presentation on this a little bit later. I'm not sure why it's not on Slack, sorry, on Zoom. But we're going to ask him to do a bit later. Okay, let's move on. All right, so this is the overview for week 1, what you'll be covering. Again, you should have all been seen this already. This is on Canvas already. We'll chat about Canvas shortly. But again, so today we just a brief overview. This is an introduction we've done so far. And we're trying to, from today onwards, get you from Excel spreadsheet to Python. And we're actually skipping a lot of the basics that you'll typically learn on a Python tutorial. We're trying to get you from what you're familiar with to using Python in the quickest way possible. And then we cover various other important topics like ETL, extract, transform, load, EDA, and for Wednesday, and then Bash terminal on Thursday, file management, and then some other topics which we're going to cover Friday as well. But again, it's something that everybody should benefit from. And for week 2, Monday, Tuesday, machine learning focus, Wednesday, probability and stats, and again, Thursday and Friday, NumPy, SciPy, ordinary differential equations, and Monte Carlo methods for Thursday afternoon. And this section you should follow on from Wednesday section where we did probability and stats, and then chemistry, computational chemistry and bioinformatics on Friday. That's a brief overview of the timetable so far. Mteto's there, just give me a moment. Okay.
Benjamin, I'm trying to check with Mteto whether we can get him on. If he's...
So Slack, as I've tried to emphasize to everyone, is our primary medium for communication. So please don't email me or email anyone about the Coding Summer School. It'll be ignored. Only use Slack for that. Just remember, we have 800 students. I cannot respond to 800 emails, so only use Slack. Everything else will be ignored. But I'll go through this other Slack criteria we'll go through, but this is just an overview. And then Zoom, as you might be aware, we're using Zoom, streaming all across the country at the various physical venues right now, and recordings will be made available. Canvas, all the content that you'll be working with is on Canvas, and the quizzes as well, and the projects you'll be working on, and our notes, translated notes will be there too. So, so looking from Teto. There we go. Teto, can you hear me? I think you need to Teto, there's no, I can't see your audio. You have to probably reconnect and connect your audio. All that. Okay. All right, so that's in terms of the logistics, and I think another important thing is to speak about certificates. So again, this is a hybrid coding summer school. So we actually want students to physically attend. So week one, we expect you to attend 80% of the time. So at least one day, we'll give you grace for not being there. Week two, 60%, so 2 days roughly. And we do that because Thursday and Friday, these are very specific domain applications. So you might have no interest in that topic for that day. So you don't have to join it. But again, we want you to be at the physical venue to learn from each other and ask questions. So this is why we want you to come to the event. And for that case, we'll give you a certificate. If you're only attending online, we'll give you a letter of participation. And the other criteria you can look through, but this is all on Canvas. So this is just a brief overview of what to expect. Yeah, thank you. And that's it. We have been a bit delayed with starting up, but we'll give a bit of like 5 minutes just for everybody to get comfortable before we start the official content for today. So I think, Mateto, are you there? You can unmute yourself. I think yeah, you are there. Okay, let me go back to your slide.
Good morning, everyone.
Morning.
Good. My sincere apologies. I had a technical issue. I couldn't sign in, but I'm here now. So, yes, bantwana bahle, mzikantu, matholo mgquba, ngumthetho sovaha lo uthethayo. This morning, I want to talk just briefly about the ongoing efforts at the CHPC to effect parity on the language barrier and its effects on teaching and learning. We acknowledge that the technology landscape is continuously evolving, while native languages tend to be relatively stagnant in time. Consequently, native languages tend to run out of terms that precisely describe new technological advancements. So our contribution at the CHPC to sustainable coding, programming, and HPC outreach has been the translation of all our educational content into the 11 official languages in South Africa for now. The translations are done by CHPC staff members because we understand what the computer language and what a computer program may be trying to do. And our approach to doing this, by all means, attempts to conserve the specific native language's heritage by using proper descriptive terms instead of relying on the informal and modern practice of simply putting the prefix I in front of everything. In the field of computing, this is a novel exercise in South Africa. Our Coding Summer School brings together participants from all 26 universities scattered across the 9 provinces of our country. And having embarked on this process more than a year ago, we have learned quite a lot, and we will continue to build on what we have already done to kind of expand our reach and level the playing field in our country and beyond our national borders. So the plan is to keep on building and extend our reach, ensuring everyone has a fair shot in the world of computing. And there's a lot more to come, and we are excited about the journey ahead. And so I thank you.
Thanks so much for that, Mteto. We'll get a more of a overview of what has been translated so far in the next few days, but thank you for the introduction. Yes, so we're actually at the end of the welcoming, so thank you everyone. We'll take a short minute break just to allow everyone just to get comfortable before we start. We still have the break at 11 o'clock. But we'll just give 5 minutes just to everybody to get ready. Any questions you can please put in Slack only. We're not responding to any Zoom questions. If you have any questions, comments, put it in the Slack and we'll start then. Thank you very much.